to record this, but also I want to show you how to set up your calculator. Let's say you've already bought your calculator and now you're going to set it up. And so here's what I'm going to do. Yeah, that's pretty good. I think if I go like this, yeah. See, I told you there was a method to my madness here. Hey, what the? Hello. I was sharing my screen. Oh. Okay. Phew. All right. Let's see. How did I have it? This way. So I find this way, it is a little bit glitchy. Oh, come on. Hello? It was good for a second, right? I don't know. I don't know. Maybe tilt your heads. That works, right? Okay. Okay, that's pretty good. Had to do it pretty weird up here, but that's okay. So let's assume that you've bought your calculator. If you haven't, they're on sale on Amazon for $30 right now. Limit 1 per customer. So you can't buy a bunch and sell them. I know, I tried. But make a killing. $2 each. Yeah. Okay, so you've got this fancy calculator. Well, it doesn't look that fancy. We're gonna turn it on, and first thing is you've got 0.00. So that's just telling you that it's gonna give all the answers to 2 decimal places. That's not very helpful, right? And so we wanna have all the decimal places that we can get, right? And so the first thing that we're gonna change is the format, okay? And so what we're gonna do is you're gonna hit the second, and then format is down here over the decimal, okay? You only have to do this once, but usually if you're borrowing a calculator from the library, they'll always reset them when they get them back. And so you'll have to, if you're borrowing a calculator, then you might have to set it up again. But so you go second, and then format, and it'll tell you that it's taking 2 or giving you 2 decimal places, right? And so to change that, we want 9, that's the maximum. So then you go 9, okay? Notice that we lost the equal sign. It used to say decimals equals 2.00. Now it just says decimals 9. To save it, we have to hit enter here. So we hit enter up here, and now we've got that equal sign, and that's how we know it's gonna save. Okay? And another thing that we're gonna change, right, kind of part of setting up our calculator, this is all in your textbook, you probably read it already, you're all good to go, but it's nice to have a little video to show you, okay? So what we're gonna do is, we're gonna use this down arrow, so there's an up and a down arrow, so there's lots of different options that we can roll through, and so if you go down, we'll just ignore these for now until you get to CHN, okay? CHN is just telling you that whatever order you give me things in, I'm just gonna do them in that order. That's not how we do math, right? We have to use BEDMAS. And so to change that, you're gonna go second set. So up here, there's a set button, okay? And that's how we're gonna change between the two options. So second and then set, and it should say AOS, which is the algebraic operating system. Doesn't matter, okay? But now it's a little bit more clever when you're giving it functions and things. Okay. Well, I think that was it for setting up your calculator. Like I said, these are all in section 1.1 of your textbook. So if you ever get one and your decimals are off or something like that, then just go back to section 1.1. Okay. But once we've changed those two things, right, 9 decimal places, and we want to have AOS, then we can get out of here. And so we want to go quit. So you have to hit the second and then quit. So second, quit. Now let's give it a whirl just to see. So something like 1 divided by 3. Now I get all these decimal places, right? So just double check that you are getting 9 decimal places now, right? If not, then maybe go through those steps again, or let me know after class and I'll help you out. Okay? The problem with it rounding the answers is that it doesn't actually keep the real numbers. It just works with the rounded numbers. And as you'll see later on today, that's not good, right? So, okay. Any questions about the calculator setup thingamajig? Great. Let's go back in here. Make sure, great. Here. Oh, that's old. Start a new note. Oi. Okay. So that was section 1.1. It's not really a section, so I put it on Google just recently. I didn't initially. Oh, and this is when I want to have it like this. Aha. And now I sit down here. So boring. Okay. So, I want to talk to you just briefly about some course resources that you have. Okay, so I don't know the business tutor hours yet, but I think they're working on them in the Learning Center. But there is free business tutors for you to use, right? And so there's a lot of free resources that not everyone knows about, right? So there's a business math tutor, right? Kate Sidlar is in the Learning Center. She's really good. And then she usually hires someone to help her out. And so there are just some resources to keep in mind. The first one, most important one, is the Learning Center. Which is free tutoring, in case you didn't know. And they do lots of subjects. Right? And like I said, they have business specific tutors, which is really good. So once I have those times and who's doing them, then I'll let you guys know. Right? You're always welcome to come see me, but I know I can be kind of scary, I guess. I don't know. But the Learning Center has free tutoring in the library. Right. So I would definitely at least check in once just to see what it's all about. They've got extra worksheets and things like that. Right. I haven't heard anything about the SL sessions. Have you heard about SL sessions before? No? So sometimes, some classes, because business math is a really big class, there's a lot of courses, right? So then a student who's taken it before will come and sit in a specific class and kind of help you with tutoring that way because they were there. So I never get the SL leaders. I'm pretty bummed, but there will be someone who's going to these classes and kind of doing the same thing that you are, which is helpful. So, wait, what the? SL sessions. I'll just put TBA to be announced because I don't know when they are. And then the business tutors. I think they're in the Learning Center. Oops. And of course, there's always Khan Academy. In case you haven't been on Khan Academy, do you guys know Khan Academy? Yeah. It's just online, yeah. Sal Khan, pretty cool dude. Khan Academy is also really good. Okay. Often what I find with Khan Academy is it's hard to figure out what you need help with, right? And so if there is something that you're struggling with in particular, then just ask me what it might be called, right? I can kind of help you out there, right? Or you can just come ask me. I'll be your Khan Academy. How about? Okay, any questions before we get into the swing of things? No? No questions? All right. So we're gonna start in section 1.2, order of operations, essentially BEDMAS, right? I know this is old hat for you guys, and probably the first week here, if you're feeling even a little bit strong in math, is gonna be pretty boring, but just sit back and enjoy it, because it will get harder, right? But I just wanna make sure that everyone's on the same page, right? So that's why we're reviewing things like BEDMAS and fractions, how they work, and just kind of all that stuff, right? So it's good to brush up on these things. So 1.2 is the order of operations. So BEDMAS, it tells us the order of our calculations. Okay. Now I know I assigned some reading, right? So you've probably already read this, right? And so that's a good thing because then it's review, right? It's always easier to hear something the second time, right? Even if it didn't make sense when you read it, at least you've seen it and you've kind of worked through it in your mind, right? So then when I talk about it, hopefully it'll make a little bit more sense. Okay. But remember, brackets, exponents, division, multiplication, addition, and subtraction. Brackets, exponents. Exponents are just powers, right? Division, multiplication. Actually, division and multiplication are on the same playing field, right? So you're gonna do those in the order that they appear from left to right. Okay? Same thing with addition and subtraction. They're also on the same playing field, and so you'll do those as they appear, right? Addition, subtraction. So division and multiplication and addition and subtraction oops. So just bless you. just write down what I just said. So if there is division and multiplication, right, then you do them in the order that they appear from left to right. Right? Same thing with addition and subtraction after you've finished all the multiplication and division. So if there is both multiplication and division, we do them in the order they appear from left to right. Same goes for addition and subtraction. Okay. So let's have an example. We'll do example 2 together. Example 2 says Z is 2 minus 3 plus 6 in brackets divided by 3 plus 1 times 9. Oh. So if we're sticking to the rules of BEDMAS here, we've got brackets. So first thing we need to do is deal with what's inside the brackets. If there's brackets inside the brackets, we have to deal with those first, right? So we work our way through to the very core and then we bloom out, right? So the 2 stays the same. 2 minus 3 plus 6, that's the one we have to simplify. We can just add those up. There's no extra things in there, right? We're just adding. So 3 plus 6, we've got 9 divided by 3 plus 1 times 9. So everything else stays the same except for the brackets. Of course, if you're doing this problem on your own, you don't have to show as many steps as I'm showing, right? But because we're going through and laying out all this groundwork, I'm going to show all the steps, or try to show all the steps. Sometimes even I forget some steps or skip some steps. All right, so next thing we've got here is, well, we've got a 9 divided by 3, and we've also got 1 times 9, right? Because we went through, we did our brackets, those are done. We checked for exponents or powers. I don't see any, right? So I'm skipping that, we're done there. Now we're going into division and multiplication, right? And so we've got 9 divided by 3 and 1 times 9 that we have to deal with, right? And so we're just gonna do them in the order that they appear, right? So we've got 2 minus, and then 9 divided by 3 is 3, and then plus 1 times 9 is 9. Okay. Now all we're left with is subtraction and addition, which again, we're just gonna do in the order that it appears. Okay. So 2 minus 3 is -1, plus 9, I'm at 8. All right. Feeling good? Good. How about example 6? $72 divided by 3 times 2 minus 6 is what? So again, we've got these brackets we have to deal with. So we've got 72 divided by 6 minus 6. Okay. Here's where we can kind of go wrong. I'm going to move my equal sign. I can do that. Messes up your notes a little bit. But first, so let's talk about, so you've got division and subtraction, right? Might be tempting to do 6 minus 6, but that's no good, right? We have to deal with the division first. And so we've got 72 divided by 6 is 12. Let me just highlight which one I'm doing here. Minus 6 is 6. Hey, Chatty Cathy's back there. What if we did 72 divided by 3 times 2 squared minus 6? Similar, right? But now we've got a power in there. Okay. So what we have to deal with first, right? Brackets first. So then we go into our brackets, but then we start over, right? We start looking for brackets. There are none, but there are exponents now. So we're going to have to deal with that exponent before we go with the multiplication, right? And so first thing we're going to have to do is we're going to have to deal with this guy before we multiply. So we've got 72 divided by 3 times 4 minus 6. And now we're back to essentially where we were before, right? Where we've got 72 divided by what's in the brackets is 12, then minus 6, right? But again, we have to do the division first before we can subtract. So we've got 6 minus 6. Ta-da. Any questions so far? Like I said, chapter 1, just pretty well a review of things that you should know, right? And so if any of this is feeling unfamiliar or even a little bit shaky, then definitely spend some time and go through these. But example 8. $500, big square bracket, little round bracket, 1 plus 0.06 divided by 2 to the power of 10 minus 1 over 0.06 divided by 2. This is math that we'll need to use a lot of, right? So this is where I need you to be working at, okay? And I know it looks nasty, but it's just brackets and exponents, and it's not that bad, right? And so we've got big brackets, so then we go inside. Do we have brackets inside? Yes, we do. So we go inside those brackets here. So inside these brackets, right, we have addition, but we also have division, right? And so going through BEDMAS, we have to do the division first before we can add it up. Okay? So let's do that. Okay? One thing that I will note is the numerator and the denominator, right? So this is a fraction. Yeah, let's talk about some terminology first. So a fraction is a numerator over a denominator. Now how I remember these is, okay, well, the numerator is on top because it's numero uno, right? So it's got to be on top, right? And then the denominator is just not the numerator, right? And so we'll have to keep in mind this terminology, right? We've got a fraction here, and what I was about to say was that we're going to simplify the numerator and the denominator separately, right? And so it doesn't actually matter when you simplify which. You can do them kind of side by side if you want to. Right. And so what I'm going to do in this cheater step is when I do 0.06 divided by 2 up here, I'm also going to simplify it down here just because I can. Right. So we're treating them separately. We simplify the numerator and denominator separately. Okay. So I'm going to do the 500 just stays 500 on the outside, right? That's just going to hang tight until the very end, okay? And what I want you to get in the habit of doing is stacking your equal signs, right? So your equal signs should all be on top of each other. Unless you're completely out of space, then stack them, stack them, stack them, and then start a new stack on this side, right? So whenever it's possible, I want to see your equal signs stacked. And that's just math proper. Okay. So everything else stays the same. The only thing that I'm simplifying at this step is the 0.06 divided by 2. So I've got 1 plus 0.06 divided by 2, 0.03. That's all to the power of 10 minus 1. And because I'm simplifying these separately, right, I can also simplify the denominator because it's just one term, right? 0.06 divided by 2, which is also 0.03. But if you wanted to keep writing at 0.06 over 2, that's fine until whatever point you decide to change it. But I'm lazy, so 0.03. Okay. All right, next step. We got our brackets, so now we go back to brackets, exponents. Okay, well, we've got brackets inside brackets. Inside those brackets, we have 1.03, right? 1 plus 0.03. So here, writing it out again, 500, all in brackets, 1.03 to the power of 10 minus 1. Divided by 0.03. Okay. I don't actually need those brackets around the 1.03 to the power of 10. They're not doing anything anymore, right? Because it's just one number to the power of 10. But I'll just keep them on there. But now when we go inside our brackets looking for more brackets, these ones don't really count, right? So then we're going on to exponents. So we've got 1.03 to the power of 10. We have to deal with that now. And so we've got 500 and 1.03 to the power of 10. I'll show you guys how to do it, I guess. Okay, here we go. All shaky. Whoa. How about this? Where's the, it's here, right? Okay. What's good here? It's a real space solver issue. Okay, it's working. Just zoom in a little bit, scoot down, okay. So if I want to do 1.03 to the power of 10, right, we're going to use this y to the x button. So it needs to have the base already on the display, so 1.03. And then I hit the Y to the X button. It's not gonna do anything on your screen, so it's hard to know if it's got it, right? But it Y to the X, and then the power of 10, put that in, and then hit equals. Okay. What we should get in the habit of doing right away is we want to save all these decimal places. You don't want to write them out, right? I understand that. But you have to save all your decimal places until the very end, right? So you're not going to round anything because this is money. So that's important, right? So you don't want to round any values, get lazy, but you do want to keep all these values, right? And so we're going to use the store button. Okay, so there's a store and a recall button. And so you can store whatever is on the screen in any one of these values, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. You can even store in 0, but I never do. I don't know, it's just not for me. So if we hit store and then 1, it'll store that value in the 1 button, right? It's not gonna replace 1, but to pull it out, I'm gonna hit the recall and then 1, and that'll pull up that value in its place. I'll show you what I mean. So we've got, I'll store this in 1, okay? And now if I clear my screen, and if now I do recall 1, so the RCL 1, recall 1, there it is, right? So it just remembers these values, right? So that'll take some getting used to, but it's going to be very, very useful later on, right? Forever. Okay, let's see if I can remember. Yeah, I've got it here. Okay, so for example, later on, we were going to do 1.03 to the power of 10. Okay, so we've got that 1.03 to the power of 10. I've stored it in 1. Doesn't matter how you got that on the screen, right? But the next thing I have to do is I have to subtract 1, right? I'll write it in the notes, but let's just go through while I have the calculator up. So we're going to subtract 1 minus 1. You might want to store this if you want. Who knows when you're going to need it. Now you have to remember where you stored them, right? But you can store that in 2, for example. So that's the numerator, right? Now we have to divide by 0.03. So divide by 0.03. We got 11.4638, whatever. Last thing we have to do, you can store that if you want to, right? Sure. Store that in 3, why not? Because we can. Last thing we have to do is multiply by 500. So times 500. I get this, 5,731.939, blah, blah, blah. Okay. So let's go through and I'll show you how I would show that in my notes. Because what you can do is you can just go through and do these calculations and just make little notes to yourself where you've stored these numbers, right? But also telling me that you've stored these numbers. So even if you're not writing out the whole number, you can just say, oh, I stored it here, so I don't need to write it all out. For example, 1.03, I stored in 1. So if I do recall 1, I've got 1.3439. And up above here, I'm going to say more of a note to myself than math, right? It's not real math. More of a note to myself saying, oh, what the? Hey, my pen's over here. that I've stored that number in 1, minus 1 over 0.03. So then I've got 500 still on the outside, and then I've got 0.3439 dot, 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 which I've stored in 2. More of a note to myself than anything else. Divided by 0.03. So you're still showing all these numbers. It's just a little bit shortened. Right? Times 11.4638. Sometimes I get carried away because if I don't want to round or whatever. But this was stored in 3. And then if I times that by 500, I get the final answer of 5,731.939656, which in money, right? Money is only 2 decimal places. So then you have to round appropriately to 2 decimal places, right? Which in this case, 5731.94. Okay. I'm just going to make a note here that in general, you have to keep as many decimal places as you possibly can throughout your calculations until the very end, where you can round to however many decimal places I tell you to, or if it's money, it's understood that it should be 2 decimal places. Okay. So in general, always keep as many decimal places as you can until the very end. Okay. Money will always be rounded to 2 decimal places. Which I usually just abbreviate DP, decimal places. Introduce it now. Let's say, for example, that you did this calculation and way up here, when you did 1.03 to the power of 10, and let's say you only used 2 decimal places, 1.34. Right? What if we go through and we calculate this with just 1.34? So I'm not going to show you because you'll do it alongside me here, but 1.34 and then minus 1 divided by 0.03 times 500. If we hadn't rounded, or if we had rounded, sorry, I get $5,666.67. Okay. If this was your money, which would you rather have? 5,700 or 5,600? I think I picked that one, right? And so that's why we can't go around rounding values whenever we feel like it. We want to keep all our decimal places until the very, very end, right? Then we can be sure that all the money is accounted for. Okay. Let's just make a note here. If we had used 1.03 to the power of 10 equals 1.34, we would get 5,666.67. Uh-oh. Okay, that's a big deal. Any questions about that? So like I said, this is the type of equation that we have to be really comfortable working with, right? So not those quick, easy ones, but more like this, right? They get slightly bigger, but that's it. Okay. All right. A lot of the time, we'll use variables or we'll have variables that we have to deal with. And so a variable is just a placeholder for a future number, right? And so a variable, is a placeholder for a number, usually denoted by a letter. For example, we've got 7a. A is the variable, and 7 is the coefficient. Just some terminology. So if we've got an expression with variables, what we have to do to simplify it is we have to collect like terms, right? And so A's go with A's, B's go with B's, A squareds go with A squareds, etc. A lot of the time we're going to be using X's, right? But X is a variable as well. Or something like 7x. X is the variable. 7 is the coefficient. Doesn't matter. So to simplify an expression, with variables, we need to collect like terms. That probably sounds familiar, right? It's where you collect all your x's, all your x squareds, and then you can combine the coefficients. Right? Collect like terms to combine the coefficients. For example, if we have to solve for A and we've got A is 60 divided by, or sorry, plus 4. Then divided by 4 minus 3A. Easy enough, right? Solve for A, it says A equals this, great. But the pickle is that we've got 3A on the other side, right? And so not all A's are on the one side. So we have to collect like terms. And so that's when your probably gut reaction was to say, oh, I have to bring the 3A over to the left-hand side. It doesn't matter which side you move things to, right? But the idea is you want to have all your A's on one side and everything else on the other side. I thought it was a fire alarm. So here, right, you could go through all the work and bring this over here and bring this over there, but that feels like a lot more work. Right? So you can still do it, but I wouldn't. So here, you guys remember how to bring the, so you've got minus 3A on this side, So to bring it over here to the other side of the equal sign, we have to add 3a to both sides. I usually don't show that work, right? Where I do +3 and +3. I just say a +3 here. And so, but I am adding 3a to both sides. So I've got a plus 3a is 604. No. So now I've collected like terms. Collected like terms. Right, I've got all my a's on one side. I can simplify 60 plus 4 and then divide it by 4. Right, inside the brackets first, I get 64 divided by 4. Kind of dealing with both sides at the same time. Right, I can say, okay, well, a plus 3a is 4a. Right? Technically, there's an invisible 1a if I just have a, right? So then I've got 1a plus 3a is 4a. And then I've got, okay, here we go. 64 divided by 4, 16. I've still got 4a on the one side. Other way. So we want to get a on its own, right? We're trying to solve for a. And so what we have to do is we have to move the 4 over to the other side. It's multiplying here, so to move it over, we have to divide both sides by 4, right? So we've got a is 16 divided by 4, and so a is 4. Woohoo! Any questions about that one? Cool. So whenever you're working with equations, right, or even expressions, do you guys know the difference between an expression and an equation? So if I write things like an expression is something like 4x squared plus 3x minus 2, for example. Whereas an equation, it doesn't really matter, but it'll come up when I talk about things, right? An expression or an equation. Or an equation would be something like 4x squared plus 3x minus 2 equals 15, right? So whenever you have this equal sign, then it's an equation, right? So whenever you're working with an equation or even an expression, okay, an expression, you have to keep it all the same, right? So you can do things like multiply by 1. You can change the makeup of numbers, right? So if you have 18, for example, you can rewrite that as 9 times 2. That's safe. Nothing's changed, right? Same idea. If you have an equation, right, as long as we're doing the same thing to both sides, right, so that they stay equal, then it's legal, right? As soon as we start doing things just to one side, that's where we have illegal math. Okay. So when working with equations, whatever you do to one side, you must do to the other side. Otherwise, the equality will be lost. Otherwise, the equality, right, the equal sign will be lost. Let's solve for x here. If we have 3x plus 2y equals 10x minus y. Right. Now we've got two variables. We've got x's, we've got y's. I don't see any others though, so that's nice. I'm trying to solve for x. I don't know what y is, but that doesn't matter. Y is just going to stay y. And so same idea, right? I want to get x's to one side, and I want to get everything else on the other side. So usually for me, unless it's way too much work, I like to move my x or whatever I'm solving for to the right, sorry, to the left-hand side, everything else on the right-hand side. But that's just me. Okay. So what I'm going to do is I'm going to bring my 10x over to my left-hand side and bring my 2y over to the right-hand side, even though it gives me a negative, and I don't like negatives, but they're unavoidable. So what I'm going to do here, 3x minus 10x, right, I'm doing that switcheroo in one go, and then I've got negative y minus 2y. Right. Because this guy went over here, and this guy went over here. I can't remember if let me just check if I posted it on your Moodle sheet or on your Moodle page. Oh, come on. I don't think so yet. No, not yet. But anyways, so I'll post the link to this website. Okay. This is put up by the Learning Center. And so Kate there has gone through and made all these worksheets. So all these worksheets and all these solutions to the worksheets, right? And so for things like solving for x, if you feel like you need a bit more work, right? And this is very similar to what we're working on right now. Then you can go through and do all these practice problems, right? So for these kind of starting problems, there will be worksheets for everything that you need to be able to do, right? And so I know it looks like a lot. Did you guys do a Mad Minute in high school?
Yep.
Yeah. Anyways, you get a minute to do 100 questions. But anyways, you can do that. So I'll post the link to this. But there's things like BEDMAS and FOIL, which we'll get to. We'll talk about fractions today, right? And then solving for x. Just all of these work problems that you can do. Okay. All right, back to this problem. So we've got our x's on one side, our y's on the other. So now we can collect like terms, right? I got 3x minus 10x, 3 minus 10, right? I can just combine the coefficients. Technically what I'm doing here is I'm pulling out the common x, and I'm pulling those out, putting 3 minus 10 in brackets, right? -7, multiplying it by x, right? I don't show that because I just write -7x, but that is what I'm doing in the background. Yeah. So then same idea here. We've got -y minus 2y, same idea. If you pull out those common y's, right, you can just put those to the side for a little bit. And then you've got -1 minus 2. And then, so -1 minus 2 is -3. And then tack the y back on. We want to solve for x, not -7x, right? So we're close, but not quite there. So to get x on its own, we have to divide both sides by -7. So we've got -3y over -7. I'd be happy if you left it there. That's fine. We do have this negative over a negative. Those go away, right? Those cancel. Technically, it's -1 times 3 times y, -1 times 7. So you can cancel those negative ones. And so that's why they cancel. So we've got 3y over 7 and x. Any questions about that one? Right. How about example 12? You're just going to combine like terms. Thought about skipping this one, but it's okay. So we've got 1.0164x plus 1.049x minus x plus 3x squared minus x squared plus 5x squared. Take a quick minute to work that out. What you've probably found, even if you're not quite finished, is that the like terms are already collected, right? So x's are with the x's and the x squareds are with the x squareds, but that would be your first step where you have to go through and figure out, okay, collect all my like terms without really changing anything, right? So here's all my x terms. And here's all my x squared terms. So to combine these x terms, here's where it's going to be important to remember the minus x at the end, right? Because it has a coefficient of -1, right? And so we don't want to forget about that little guy. And so what I'm going to do, just to make sure that I don't forget about them, is just pull out that x, that common x. And it doesn't matter how you did it, right? As long as we get the same number in the end, I'm sure it's fine. But 1.0164 plus 1.049 minus 1. Right? Those are the coefficients that I'm dealing with. Plus, I'm going to do the same thing with the x squared, right? I'm going to pull out an x squared, the common x squared. Whoops. And then I've got 3 minus 1 plus 5. Because what I see a lot of is when it's just minus x or minus x squared, you forget to take away 1, and it can make a huge difference. Right? And so I get 1 point. Technically, it's, I guess I should be proper here. x times 1.0654 plus x squared times 7. But usually I wouldn't write it out like that because for me, coefficients always go in the front, right? And probably for you too, I don't know. But I always write the coefficient in the front. So 1.0654x and then plus 7x squared. Another thing is that it's good to get in the habit of writing polynomials. So this is a polynomial, just where we have multiple variables, x squared and x. We have a polynomial. It's good to write them in descending powers, right? So we would write the 7x squared plus 1.0654x. Yeah. So let's start out here. 1.0654x plus 7x squared. But really, I would write 7x squared. And at this point, it doesn't matter. 7x squared plus 1.0654x. Okay. It's a good idea to write polynomials in descending powers. Or it's a good idea to write, I'll just say expressions in general here. Expressions with powers in descending order. Seven x squared plus 1.0654x. X squared, then x. And then the number if we have it. Okay. Yeah, sure. Let's do example 14. How about? Again, we're just solving for x. This one? Yeah, I mean, if you wanted to, you could just look at this and do it, right? You don't have to show this, like breaking them up like that. Is that what you mean?
If we like break this equation into parts, from 3x squared minus x.
Yeah. Well.
If we add like 3x plus 5x, it's like 8 minus x.
Yeah.
That's what I did.
Yeah, you totally can. The only reason that I'm pulling it out, and it would be what I would do too, probably. The only reason is I'm pulling this out to show you that that is what you're doing in your head. You just don't know it, right? But what you're doing is you're saying 3 minus 1 plus 5, right? But that's what you're doing here, 3 minus 1 plus 5, right? And so you're already doing it, and that's good, right? But here's kind of why. Yeah. So this is kind of the mathy version, but if you got to the same answer, you're good. You're not getting the same answer? But you're getting this one, right? It's just this one? So just make sure that you don't forget about the minus 1. Right, usually that's the one because you've got minus x, right? And so usually people lose the minus 1 because you've got 1.0164 plus 1.049 minus 1. Is that the one? Yeah. No worries. Yeah, so usually that's the one that gets you. Let's do another one. So let's solve for x. You've got 25,000 is x plus x times 1.05 to the power of 1 plus x times 1.05 to the power of 2 plus x times 1.05 to the power of 3. So earlier, we were dealing with the powers on the x's, and that's when we have to collect like terms, but 1.05 to the power of 3, for example, is a number, right? And so what we're gonna do is we're gonna go through and find those values, and then we've just got the coefficients of x, right? But the only variable that we're dealing with here is x. And so if we go through, so we're stacking our equal signs, right? And this is a kind of a rare occasion where as long as nothing's changing on this side, you can leave it blank, right, until it does. Not that it changes a lot, but anyways. So you've got x plus 1.05 to the power of 1 is just 1.05 times x plus 1.05 to the power of 2 is 1.1025, and then times x. And then 1.05 to the power of 3, right, just using that y to the power of x button on your calculator, is 1.1576, oops, 76, oh, come on, 25 times x. Oh, if I'd been more clever, I would have stored these numbers, right? But I forgot, right? Because not that these are huge, right? But if I had stored, you know, store in 1, store in 2, store in 3, then I could just do recall 1 plus recall 2 plus recall 3. I'll get there. It's early in the term still. Okay, and I have a cheat sheet, so I already know the answer. One thing that you do have to keep track of, right? Don't forget about this lonely x, right? There's still one x here, okay? And so you want to do 1x plus 1.05x, 1 point blah, 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 blah. That's not helpful, I know. But you should get 4.310125x, right, is 25,000, right? So just make sure that that's what you get. If you get 3.3, I know you forgot the first x, right? If you got something else, I don't know what happened. So now we know that this equals 25,000. So to solve for x, I'm going to want to divide both sides by 4.310125. Okay. Now, for me, if I'm solving for x, or whatever I'm solving for, I always want to have it on the left-hand side. For me, it just looks a lot better to have x equals whatever. Okay. So usually what I end up doing in my notes is right away here, I would say x equals 25,000 divided by 4.3, right? So I've just kind of swing doored. It's the same, we've got an equal sign, right? But that's what I'll be doing, and it can be confusing in the beginning, right? But all I'm doing is I want to have x on the left-hand side. So I end up writing x is 25,000 divided by 4.310125. what I should have done that I didn't do, I should have taken it slow and written this whole thing over here equals 25,000 and then gone to this step, but I skipped it. So, okay. But I think we can all agree that it's the same. Right? And so we've got x is 25,000 over 4.3, whatever. So we've got 25,000 divided by 4.310125. X is 5,800.295815. Pardon? That's right. Yeah. So because it's money, right? 25,000 divided by 4 point whatever is still going to be money, right? And so at the very end, what we're going to do is we're going to round properly to 2 decimal places, right? And so X in money is going to be 5,830 pennies. Yeah.
So since we're shifting the 25 to the right side, are we not also supposed to change it to minus 25,000?
So what I did was less fancy than that, because all I did was I took this and I said, no, you go over here and you go over here, right? So I just swung it around, right? So it's just a mirror image, right? And so I didn't actually do anything. I just went like this. That could be a dance move. Always coming up with new ones. All right. Feel free to use it in the club. Okay. All right. Any questions about that? Okay. So the last thing we're going to talk about is fractions. I'm just going to review how do we multiply and divide fractions, because it's actually easier than adding and subtracting, but then also we're going to talk about just adding and subtracting fractions. Okay. So we've got 1.3 here. I think they've started giving me page breaks in this app, but I don't really know. See how one line goes a little bit further than the others? I think it's page breaks, I'm not sure. So 1.3 is on rational numbers. Which are fractions. We've already talked about fractions, so it seems backwards to have worked with fractions and then talk about how fractions behave, right? But remember that a fraction is a numerator over a denominator. Okay. So, first thing I want, and I'm switching the order from the textbook because the textbook goes through and of course shows you how to add and subtract fractions, but to add fractions, you actually need to be able to multiply fractions. So that's why I'm doing it in a little bit of a different order. But so multiplying fractions is probably the easiest thing, right? So if you have 2 fractions, then you just multiply across the top, multiply across the bottom, right? So to multiply fractions, We multiply across the top, which is the numerator, and across the bottom. For example, if you've got A over B times C over D, right, just using variables because that's the most general way that we can talk about math, it would be A times C over B times D, right? So just multiply across the top, multiply across the bottom. For example, we've got 38 over 55 times 15 over 2. Let me just check here. Yeah. To figure out what that is, right? We've got 38 times 15 on top and 55 times 2 on the bottom, which gets us 570 over 110. I'm confident that that simplifies, but I don't really care, right? This number is the same as the simplified number. So for our purposes, I'm not going to put a lot of emphasis on simplification because it doesn't truly matter, right? So once you're here, that's great. You're done. Let's see though, 570 on your calculator divided by 110. This is the exact number, right? And I actually prefer to see that it's approximately equal to 5.1818, and it seems to be repeating the 18, right? I don't know about you guys, I like decimals. I think they're easier to work with than fractions, right? But one thing to keep in mind is that a decimal is only approximately equal, right? This is an exact answer, and so that's good. Right? This is an approximate answer, right? So that's why I like to just kind of show that with a squiggly equals, right? Because it's important to keep in mind that, okay, we've got an exact answer, a decimal is just an approximate answer. Okay, so there's not much to multiplying fractions. You just multiply across. Even if you've got 4 fractions that you're going to multiply, you just multiply all the way across, and then you're done. Right? But how about dividing fractions? Probably easiest to show you with the variables, right? But I'm gonna talk it out first. So you've got a fraction over a fraction, right? What you do is, have you guys heard of the flip and kiss or anything like that? So you flip the denominator and then you multiply them, right? The key is to flip them and then you multiply, right? So then you're back to multiplying. But so to divide fractions, flip the fraction, technically take the inverse of the fraction, but I think we all know what flip the fraction means. Flip the fraction in the denominator and multiply it by the fraction in the numerator. For example, if we've got A over B all over C divided by D, right, then what I'm going to do is I'm going to flip the C over D, so that's now D over C, and then I multiply those. right? So this I can rewrite as A over B stays the same times D over C, right? Which we already know is just A times D over B times C, right? Just because they're multiplying. If we've got something kind of silly like this, 18 over 5 divided by 27 over 15, bless you. I don't like the divisor symbol in there. I like to write them on top of each other just because then I can kind of visualize it, right? And so I'm going to rewrite this as 18 over 5 all over 27 over 15. Because then I can hold the first one steady as just 18 over 5 times, and then I have to flip the 27 over 15 to make 15 over 27. And now I'm back to multiplying, so I've got 18 times 15 over 5 times 27. 270 over 135, which I always check on my calculator in case it's a whole number. In this case it is, so 270 divided by 135, womp womp, it's just 2. So that's multiplying and dividing fractions, which is actually easier than adding and subtracting fractions. So adding and subtracting fractions, luckily they follow the same rules, so there's not one for each. Subtracting is just adding a negative version of the number. Right? So subtracting is adding in a sense. But adding and subtracting fractions can only be done if we have a common denominator, right? So if we have the same denominator, so the same value in the bottom of our fraction, that's when we can go ahead and add and subtract, right? So can only be done if the two, I'll say or more, because we could have more than 2 fractions that we're adding or subtracting, but for us, probably just 1 or 2. 2 or 3 maybe. Can only be done if the 2 or more fractions have the same denominator. So what we have to do is we have to find a common denominator or make a common denominator. So for me, I actually prefer to just make a common denominator instead of figuring out, oh, which multiples do they have in common? Because I find that pretty time consuming, right? Oh, I could multiply this one by 2 to get to the same number. So for me, what I do is I just multiply the 2 values in the denominator, and then they're both divisors of that number, right? Because they make up for that number. So I'll show you what I mean. Let's do example 15. If we've got something like 15 over 22 plus 1 over 2. this one's pretty good, right? Because if you have to find the common denominator, right? So a common denominator here, sure, it could be 22, right? But usually our values aren't going to be as easy as 22 and 2, right? And so I'm just using this one as an example. Of course, there's going to be lots of different ways to get an answer, right? As always, but so I could say, okay, well, 22, if I just multiply 2 by 11, right, I'll get to 22. But like I said, I don't really like doing that. So for me, what I find the safest way to do it is, okay, well, if I do 2 times 22, 44, get both of these over 44, well, then I'm safe, right? Because 44 divided by 2, 44 divides by 22, right? So then I have a common denominator that both came from, right? So I like to look and say, okay, well, 22 times 2 is 44. That's going to be my common denominator, okay? How am I going to get there, though? Remember, this is an expression. It can't do anything to change it, right? I can't add 4 or do something weird like that. But I can do things like multiply by 1, right? So that's allowed. 4 times 1 is still 4, right? That kind of thing. And so what I'm going to do is I'm going to take on this side, I'm going to take 2 over 2. 2 divided by 2 is 1, right? So if I multiply this value by 2 over 2, I'm really just multiplying by 1, right? But what happens is I've got 15 over 22 times 2 over 22, or sorry, 2 over 2. So the denominator here is now 44, which is what I wanted, right? And so this, I'll just rewrite it here, 15 over 22 plus 1 over 2 is going to be the same as 15 over 22, and then I'll say times 2 over 2, and then plus 1 over 2 times, and on this side, to get a denominator of 44, I'm going to multiply by 22 over 22, right? Because that's still 1. 22 over 22 is still 1. So here I've got 22 over 22. Notice that what I did was, okay, well, on this term, I just took this, made it 1 essentially, 2 over 2. And on this term, I just took this one, 22 over 22, right? It's not cross-multiplying, but I like to think of it kind of as cross-multiplying. We can all agree, though, that, right? No? 2 over 2 is 1. 22 over 22 is still 1. So this side is still the same as this side. Right? That's the important part. Okay? And I'm just showing you what I like to do. Yeah. I think I have to see it, but yeah, let's
go to LCM for 22 and 2, and it will be 22.
Yeah. Oh yeah, so that's what I said. So definitely for something easy like this, 22 and 2, of course you can just look at it and say, oh, well, 22, right? But this works all the time, right? So even when these two numbers are really, really hard, this method will still work. And so for me, I find that it's the safest way to do it, right? But yeah, if you found the lowest common multiple, then that's great. It sounds like you've got it.
We are taught to do like LCM.
Yeah, that's good. It's harder, but it's good. Yeah, I find this easier. But that's, yeah, as long as we get the same answer, and I'll show it in a hop, skip, and a jump here. But now what I'm doing is I'm multiplying, right? BEDMAS still applies, so I have to multiply these guys and I have to multiply these guys before I can add them up, right? And so I've got 15 times 2 is 30 over 22 times 2 is 44, plus 1 times 22 is 22 over 2 times 22, which is 44. Now I've got a common denominator of 44, right? Because I forced it there. And so now I can add these up, right? And so I've got 30 plus 22 over 44, right? So it's not until I've got that common multiple that I can actually add the numerator. One thing to notice though is that the 44 stays the same, right? And so when we're adding, we're not actually adding the bottoms. We've forced them to be the same so that they can just stay at 44. And so we've got 52 divided by 44. And I would just leave it at that. Let's just try it out. Nah, it's nasty. 1.1818181818. All right. Okay. I'll make a note here. Notice the denominator does not change. Okay. Any questions? No? Let's do, nah, I think we're good. Too chatty. Anyways, that's all we're gonna cover today. So next day we'll, I think, finish chapter 1, I think, or at least make some headway. I'll see you guys on Thursday. I'll go through it in class. It's a good idea to read it so that you've seen it once before. Yeah, because otherwise it's hard to see stuff